Welcome to this Maths Made Easy video on differentiating parametric equations. And to start with, we just want to show that differentiating parametric equations is actually rather straightforward. To start with, let's recall the chain rule. And the chain rule is defined as dy by dx is equal to dy by dt times by dt over dx. Now here, we're using the product here, so this is dy over dt times by dt over dx. So if we consider this here as dt over dx, if we take the reciprocal of that, and then we divide dy by dt by dx over dt, then these are equivalent. So in that case, we can write dy by dx as being dy over dt divided by dx over dt. So in that case, what we want to do here is simply differentiate x and y with respect to the variable t. So for example, if we've got y equals t squared and x equals 3t plus 6, so x equals 3t plus 6, then in this case, all we simply need to do here, like we've just said, is differentiate x and y here with respect to t. And then in that case, we can simply apply this fact here, that dy by dx is simply dy over dt divided by dx over dt. So therefore, if we find dy by dx first, then this is nice straightforward differentiation here. This is simply going to give us 2t for dy by dx. For dx by dt, in this case again, nice straightforward differentiation here. This is just simply going to give us 3. And therefore, if we want to find dy by dx now, so dy by dx, then we're simply going to apply this formula here. So dy by dt is simply 2t, and then we divide this by dx over dt, which is 3. So we write our answer here as 2t divided by 3, and writing that as a fraction, then we simply obtain 2t over 3 there as our dy by dx, our differential there. Moving on now to take a look at tangents and normals of parametric equations. Now to start with here, we need to be aware of the fact that the gradient of the tangent is just simply dy by dx. So if we start here, the gradient of the tangent is simply dy by dx. So gradient of the tangent is dy by dx. However, we have to be careful for the normal here. The gradient of the normal is slightly different here. And in this case, the gradient of the normal is -1 divided by dy over dx. So -1 divided by dy over dx there. Okay, and that gives us the gradient of the normal there. So we need to be aware of that when we're taking a look at example questions. You will also need to evaluate these gradients for specific values of t. And like we can see for this example here, we're asked to find the gradient of the tangent to x equals t squared and y equals t squared plus 6t minus 7, and we're given our value of t here. So in this case now, let's take a look at this example here. So to start with, we've got our x and our y, and we also have the value of t for which we need to evaluate the gradient at. So here, again, what we need to do is find dy over dt and dx over dt. So if we differentiate x first here with respect to t, we obtain dx over dt, and that's simply going to give us 2t there. Okay. Repeating this now with the y, again, differentiating here with respect to t. In that case, we obtain dy over dt, and this simply gives us 2t for the t squared here. Moving on to the 6t, well, if we differentiate that with respect to t, we simply obtain plus 6. And finally, this minus 7, as that's a constant, that'll just differentiate to give us 0. Okay, so that's our dy over dt there. Now, as we want dy by dx here, because we're looking for the gradient of the tangent, so in that case, we just need dy by dx here. So to find dy by dx, we simply use the fact that to find dy by dx, this is dy over dt, dy over dt divided by dx over dt. So in that case, dy over dt, we know that's 2t plus 6, and we're dividing this by dx over dt, which is 2t. And in this case, we can easily simplify our dy over dx by dividing both numerator and denominator here by 2. And in that case, we simply obtain t plus 3 over t. Now here, we're looking for the gradient of the tangent to x at the value here of t equals 12. So in that case now, all we simply need to do here is substitute t equals 12 into our dy by dx here. So into, let's call that 1 there, into 1. So in that case, if we substitute t equals 12 into here, what we obtain then is 12 plus 3 over t, which is 12. And this will give us 12 plus 3 over, so that's 15 over the 12. And we can also simplify this here to give us 5 over 4 there. So the gradient of the tangent to x equals t squared and y equals t squared plus 6t minus 7 at t equals 12 is simply 5 over 4. And that gives us the solution to our example here. And that concludes this Maths Made Easy video on differentiating parametric equations.